to chemistry e-learning.
Welcome back to Class 9, Part 5, Chapter 1, Matter in Our Surrounding. So let's continue further. Let us go through some new terminologies related to our next topic. Compressibility. Compressibility is the measure of how much a given volume of matter decreases when placed under pressure. If we put pressure on a solid or a liquid, then it is essentially no change in volume. Rigidity. Relative stiffness of a material that allows it to resist bending, stretching, twisting, or other deformation under a load. It is a function of material's modules of elasticity and shape. So, you can understand compressibility and rigidity are two opposite factors related to the states of matter. When there is enough intermolecular space, the substance can be compressed to a certain extent, and due to rigidity or stiffness, the material resists the bending or stretching, twisting, or other deformation under a load. Fluid. A fluid is a substance that continuously deforms flows under an applied shear stress or external force. Fluids are a phase of matter and includes liquid, gas, and plasma. Temperature. A measure of hotness and coldness in degree. Temperature is measured with a thermometer which converts the reading into degree on a temperature scale, commonly Fahrenheit or Celsius. Pressure. Pressure is defined as the physical force exerted on an object. The force applied in perpendicular to the surface of object per unit area. The basis of formula for pressure is force upon area. Unit of pressure is Pascal. Atmospheric pressure. The pressure exerted by the Earth's atmosphere at any given point, being the product of mass of the atmospheric column of the unit area above the given point and of the gravitational acceleration at the given point. So, this is compressibility. Rigidity. We know that a chalk breaks easily while a rubber band you can stretch to certain extent. Fluids, any liquid or gas or any substance which can flow are fluids. Temperature, pressure, atmospheric pressure. So, let us now see solid, liquid, and gaseous states. Solids, the state of matter in which material are not fluid but retain their boundaries without support. The atoms or molecules occupying fixed position with respect to each other and unable to move freely are solids. The best example is ice. Liquids. A liquid is nearly incompressible fluid that conforms the shape of its container but retains a nearly constant volume independent of pressure. Water. Gaseous, a substance or a matter in a state in which it will expand freely to fill the whole of a container having no fixed shape, unlike a solid, and no fixed volume, unlike a liquid. The steam. Now let us compare the properties of solid, liquid, and gases on the basis of certain criteria. On the basis of volume, solid has fixed volume, liquid has fixed volume, but gases has no fixed volume. The shape, solids have fixed shape, liquid do not have fixed shape but they take the shape of the container. Gases have no definite shape and they occupy or spread over the entire available space. Intramolecular space. The least intermolecular space is there in solid because the molecules or atoms or particles are closely packed together. In liquid, the intermolecular space is more than solid but less than gases. Intermolecular force of attraction is maximum in solid, less in liquid than solid, and more in gas. Gases have minimum intermolecular force of attraction. Movement of molecule. The molecules move about their mean position due to least intermolecular space. In liquid, molecules continuously move past or slide over each other due to some extra intermolecular space than solids, and so they can flow easily. Gases, molecules move in any random direction due to large amount of intermolecular space and least force of attraction. Fluidity. Cannot flow. Solids do not flow, liquid can flow, and gases can flow. Compressibility. No compressibility, that is, cannot be compressed. Liquid, slightly compressibility, it can be compressed to a small extent. High compressibility, that is, it can be compressed easily. Diffusion, no diffusibility because there is no intermolecular space. Slight diffusibility, and gases, high diffusibility. Now let us see some more terminologies related to the chapter. Melting or fusion. Melting or fusion is a physical process that results in the phase transition of a substance from solid to liquid. So very simple, you can remember it as the process by which a solid substance gets converted into liquid substance is called melting. Melting point is the temperature at which the conversion of this solid substance to liquid substance occurs is called its melting point. Each substance has a unique melting point. Boiling. Boiling is defined as a phase of transition from a liquid state to gaseous state. Usually occurs when a liquid is heated to its boiling point. Boiling. Boiling point of a substance is the temperature at which the vapor pressure of liquid equal to the pressure surrounding the liquid and the liquid changes into vapor. In simple words, you can remember as the temperature at which a substance gets converted into gaseous form from liquid substance is called boiling point. And like the melting point, it is unique for each substance. Evaporation or vaporization. Evaporation is the process of a substance in a liquid state changing to a gaseous state due to an increase in temperature or pressure. No extra heat is manually given during this process. Solidification. The reverse of conversion of liquid to solid is called solidification. That is, when any matter that results in the production of solid from liquid substance due to decrease in the melting point or temperature is called as solidification. Sublimation. Sublimation is the transition of substance directly from solid to gaseous state without passing through the liquid state. Condensation. Condensation is the process by which water vapor in the air is changed into liquid water. Disposition. Disposition also to the phase change from gas to solid. Liquefaction is a process that generates a liquid from a solid or a gas that generates a non-liquid phase under pressure is called liquefaction. Latent heat of fusion. The amount of heat required to change 1 gram of a substance at a temperature of its melting point from the solid to liquid state without changing temperature is called latent heat. Latent heat actually means hidden heat of fusion. Latent heat of evaporation. The input energy required to change the state from liquid to vapor at constant temperature is called latent heat of vapor. Now let us see the interconversion of states of matter. Looking at the figure, if we begin with solid substance, as for example ice, when converted into water form due to increase in temperature, is called melting. Conversion of water to vapor with the increase in temperature is called evaporation or boiling. Conversion of gaseous matter to solid substance is called disposition. It is a chain process with the increase or decrease in the temperature and pressure which causes the interconversion of states of matter. It is a reversible process as well. Now, if we convert ice directly to gas, like some substances undergoes direct conversion from solid state to gaseous state is called sublimation. The conversion of gaseous state to liquid state is called condensation, and liquid state to solid state is called freezing. So, you can see the cycle of conversion of one state of matter to another state of matter with increase in temperature and pressure, and reverse cycle with decrease in temperature and pressure. Now let us see the reason for the interconversion of one state of matter to another. First reason is change in temperature. Due to change in temperature, the intermolecular space between the atoms of the substances increases or decreases. That is, if the temperature increases, the intermolecular space increases, and if the temperature decreases, intermolecular space decreases. This is because of the increase or decrease of kinetic energy of atom, which increase or decrease the intermolecular force of attraction, and due to which the change in state of molecules occur. Same way, change in pressure is also another reason for interconversion. Due to change in pressure, the intermolecular space between the atoms of a substance increase or decrease, because of which increase or decrease the intermolecular force of attraction occurs, due to which change in state of molecules occur. So now let us see effect of temperature on the conversion of states of matter. With the help of an activity, take about 150 grams of ice in a beaker and suspend a laboratory thermometer so that the bulb is in contact with the ice as shown in the figure below. Start heating the beaker at a low flame. Note the temperature when the ice starts melting. Note the temperature when all the ice has converted into water. Record your observation for this conversion of solid to liquid state. Now, put a glass rod in the beaker and heat while stirring till the water starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. Record your observation for the conversion of water in liquid state to gaseous state. You will observe that the ice started melting at 0 degrees Celsius, and on further heating the temperature didn't increase, but the ice got converted into liquid state. In the second figure, as you can see now, when it is water state, that is liquid state, on heating at 100 degrees Celsius, the water started vaporizing. So, with the increase in temperature, the substances, that is ice and water, got converted from one state to another state. Now let us see effect of pressure on the conversion of different states of matter. What will happen when we start putting pressure and compress a gas enclosed in a cylinder? Will the particles come closer? So do you think that increasing or decreasing the pressure can change the state of matter? Applying pressure and reducing temperature can liquefy gases. You can see in the figure that a cylinder with piston is filled with gas in it. Now when you apply force or pressure over it, the molecules or atoms of the gaseous state come closer, and due to the decrease in the intermolecular space, the gases get converted into liquid state. The best example of it is LPG, that is our liquefied petroleum gas, which we use in our kitchens. In this cylinder, the gas is filled at high pressure, and so it is in liquid state. When you switch on the cylinder and light the stove, the liquid gas gets converted into gaseous form and is ready for the cooking. Now let us see what is evaporation. Evaporation is the process by which water changes from a liquid to a gas or vapor. Here, the process is a natural process which occurs on a large scale. Now let us see the difference between boiling and evaporation. Boiling occurs at fixed temperature. Evaporation can occur at any temperature. Boiling is a quick process, evaporation is a slow process. Boiling takes place throughout the liquid, whereas evaporation takes place only at the surface. Bubbles are formed in the liquid, no bubbles are formed. In boiling, the temperature remains constant, whereas in evaporation, temperature may change. Thermal energy supplied by an energy source and thermal energy, that is heat energy, is supplied by the surrounding. You can observe in the diagram as well. Now let us see the factors affecting evaporation. An increase of surface area. If the surface area is increased, the rate of evaporation increases, because we understood that evaporation is a surface phenomena. So if the surface area is more, evaporation will be more. The example is, to dry any clothes, we spread the clothes, and so the surface area of clothes increases and the drying or evaporation of water from the clothes occur faster. Now an increase of temperature. With the increase in temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. If the humidity, that is the amount of moisture in the surrounding, is more, then obviously the evaporation will be slower or less. And the humidity, if it decreases, then the amount of evaporation or the rate of evaporation will be more, as the number of water particles in the surrounding will be less due to less humidity. An increase in wind speed. With the increase in wind speed, the particles of vapor move away with the wind and decreasing the amount of water vapor in the surrounding. So with increase in wind speed, the evaporation increases. Now, how does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating and the particles of liquid absorb energy from a surrounding to regain the energy lost during evaporation. This absorption of energy from the surrounding makes the surrounding cold. You must have experienced having a cold water bath in summer or sweating in summer. This causes cooling effect on your body. Have you ever observed droplets of water over the surface of a glass containing ice cold water? Yes, that is due to evaporation. Let us take some ice and cold water in a tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in air, on coming in contact with a cold glass of water, loses energy and gets converted to liquid state, which we see as water droplets. Why should we wear cotton clothes in summer? During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles at the surface of liquid get energy from the surrounding or body surface and change into vapor. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for the easy evaporation. Now let us see various units of temperature and its interconversion. The SI unit of temperature as per International System of Unit is Kelvin, which is represented by symbol K. The Kelvin scale is widely accepted or used in the field of science and engineering. However, in most part of the world, Celsius or Fahrenheit scale is used for measuring temperature. In any case, here is the relation between Celsius, Fahrenheit and Kelvin. Degree Celsius to Kelvin. The equation to convert between Kelvin and Celsius is Kelvin is equal to degree Celsius plus 273.15. For example, let's convert the boiling point of water to Kelvin. Boiling point of water is 100 degrees Celsius. Plug the value into the formula. So, Kelvin is equal to 100 plus 273.15, that is Kelvin is equal to 373.15, that is the temperature or the boiling point of water in Kelvin scale is 373.15. Now Kelvin to degree Celsius. The equation to convert between Kelvin and Celsius is degree Celsius is equal to Kelvin minus 273.15. Let us convert normal body temperature from Kelvin to Celsius. So, degree Celsius is equal to Kelvin minus 273.15. So, degree Celsius is equal to 310.15 minus 273.15. So, human body temperature in Celsius scale will be 37 degrees Celsius. Let us tabulate the formula for further conversion. Fahrenheit, Celsius and Kelvin scale. You can observe the different formulas for the conversion. Now, let us test our learning till now with the help of the exercise. We are supposed to go through all the video lectures and try to answer these questions.